What's up guys, welcome back to the channel. Today in this video we'll be doing this following previous question paper that you see here. As you can see, this is a national certificate for mathematics and 4, and this question paper was actually written on the 20th of November 2024. Now, this paper took about 3 hours to be written. Now, on this particular video, we're going to focus on question 5. Just in case you haven't watched other questions, I've already done question 1 to question 4. So I'm going to leave a link that contains a playlist with those questions. You're going to go to the description, click on that link and watch those videos. And the very same link is going to pop up on the top right of this video. So click on that icon up there. All right, guys. So before we start, though, I just like to say thank you very much, guys, for watching, subscribing to the channel, commenting, and not forgetting those who like and share the videos. If you haven't subscribed to the channel, subscribe to the channel because I've made lots and lots of videos on previous question papers similar to this one and also questions on mathematics. All right. So before I continue, I just like to let you know, guys, that I will leave timestamps for specific questions just in case you don't want to watch the question 5 in a sequence order. Now that we are done with all this intro, we're about to look at question 5 and let's see if we can able to solve it. So here's our question 5. As you can see, question 5 consists of 5.1, 5.2, 5.3, 5.4, which has 5.4.1, 5.4.2. So we're going to start with 5.1 and then we're going to copy this question here, paste it where there is space, and let's try to solve this problem. All right, let's look at 5.1. Now 5.1, they want us to evaluate this polynomial that you see here. Now this polynomial, they want us to actually integrate it. As you can see, we have a sigma there and also we have dx. This means that we are integrating with respect to x there. The sigma means that we are integrating. Whenever you see these two, it means that we are integrating with respect to x. Now, before we solve this problem, you need to understand that integration is the opposite of differentiation. So in order for you to understand or to master this part of mathematics, you need to master differentiation. Before we start, let's look at this polynomial. We must look at each term very, very careful. Now, the first term that we have here, as you can see, we cannot integrate like this. We need to simplify it because this here, it's an identity. The second term as well, we cannot integrate it because we have the trigonometric ratio on the denominator. So we need to do something about this. We need to simplify it. As for the third term and the fourth term, they are all fine. So before we integrate, let's simplify the first and the second term. Now, since we are simplifying, the sigma will also remain here to symbolize that we haven't integrated yet. So open bracket. Now let's start with the first term. As you can see, the first term here, we have 2 sine x multiplied by cos x. Now this here is a double angle identity for sine. So you can write it like this, sine 2x. Right. Just in case you don't know much about double angle identities, I'll leave a video on the description where I actually derive these double angle identities. The very same video will pop up on the top right of this video that you're watching here. Now let's go to term number 2. Now we say plus. We have 3 over sine squared x. Now we cannot integrate with this type of term here. We need to simplify it. Now this 3, we can keep it on the numerator, but then we need to use the inverse in order for us to get rid of this sign on the denominator. What is 1 over sine? So 1 over sine is actually cosec, but since this one is squared, so we must put squared there, x. So when we simplify this is going to become 3 cosec squared x plus 3e to the power of 3x plus pi to the power of 3. Close bracket, dx. Right. Now that we managed to simplify this, do not forget to also include dx because this means that we haven't yet integrated. Everything is simplified. It's time for us to integrate. So when you integrate, you can equate this to y. Now let's start with the first term. This here is a trigonometric ratio that needs to be integrated. Now you need to know the integral of sine 2x. Now the integral of sine, we know that is going to be negative cos, and then we have to write this 2x there. But then when you integrate the trigonometric ratio, you always divide by the coefficient of x. In this case, this 2 here. So you must divide it by 2 then, right? Now let's go to the next term. Now we can say plus, right? But then we have 3 here. You also need to know what is the integral of cosec squared x. Now, like I said, if you know your differentiation, you will know what is cosec squared x. The integral of cosec squared x is actually negative cot x, right? Since our coefficient here is 1, even if you don't divide by 1, it's fine, guys. Then we go to the third term. Now the third term, when you look at it, it's the exponential integral. Now we have the coefficient of everything here, which is 3, and then we're still gonna write e to the power of 3x, right? But then when we integrate this, we're also gonna divide by the coefficient of x, this 3 here, which is gonna be them, and then multiply by natural log the base, our base here, which is gonna be e plus. Now the last term can be tricky, guys. We have pi to the power of 3. If you do this in a rush, you might find yourself mistaking this with x. This is pi. It means it's a constant. Now when we integrate constant, we just multiply that constant with x. So we can just say x multiplied by pi to the power of 3. Now that we managed to integrate everything, let us not forget to add c here. This c represents that we are doing indefinite integrals and also represent the constant. Right, now that we are done, it's time for us to simplify this question further. Now, the first term, there's nothing we can do here. We just write it as negative cos 2x divided by 2. And then the second term, you just multiply by 3, whatever that is inside here. So we're going to have negative 3 cot x. And then the third term, as you can see now, we have 3 divided by 3. We want to be having 1. And then on the numerator, we're left with e to the power of 3x. But then on the denominator, we still have natural log e. Just in case you didn't know, natural log a is equaling to 1. So this thing here, this e to the power of 3x is divided by 1. You don't have to write it, guys. It's fine. Now let's go to the fourth term. The fourth term, it's fine like this. Just rewrite it as it is. X multiplied by pi to the power of 3 plus c. So guys, this here is our final answer. Just in case, guys, it so happened that you didn't understand, you can go to the comment section, comment. I will try to help you to my level best. But just in case you didn't know as well, I've already made videos on polynomials like this one, and also on each and every integral that you see here. I already made videos introducing the concept here. So I will leave the playlist of those polynomials where I solved them, and also that playlist will pop up on the top right of this video. But if this type of the video helped you to integrate this polynomial, do not forget to like, share, and also comment if you had any other comment. If you haven't subscribed to the channel, subscribe to the channel. All right, guys, we are done with 5.1. I hope this makes sense to you. So let's go and do 5.2. All right, guys, here's our 5.2 here. Now we're just gonna copy this question, paste it where there is space, and let's solve it. Right, let's look at 5.2. Now 5.2, they want us to evaluate the following definite integrals. Remember, the first question was indefinite integrals. Now this is a definite integral because we have the limit, the upper limit and the lower limit. So they want us to find the definite integral of 2 tan x. We're also integrating with respect to x. Just in case you don't know, this dx means that we are integrating with respect to x. We also have the sigma there, but we do have the upper limit and the lower limit. Now, before we do anything else, I would advise you guys to change this pi over 4, because it's in rads, into degrees. Just in case you don't know, this is how you do it, guys. You say 180 divided by pi multiply by pi over 4. This here is going to give you 45 degrees. Rather, do the calculations in degrees. So we can rewrite this and say sigma 45 degrees, the upper limit, and the lower limit is going to be 0. And then you say 2 tan x dx. Remember, we are integrating with respect to x. Now, when you integrate here, guys, you're going to integrate what is inside the bracket here. So we can say y is equal to, now you must have a bracket then. You can say 2, and then from there, what is the integral of tan? Just in case you don't know the integral of tan, the integral of tan is natural log sec then x, and then you close. Guys, the definite integral, we do not add c. It's not necessary. You can add it, but it's not necessary because at the end, they're going to cancel each other. And then here on top here, you're going to write the upper limit, right? And then here, you're going to write the lower limit, which is 0. Guys, this is the upper limit and that is the lower limit. These are not powers, just in case you get confused. These are not powers. This is to show you that you have the upper limit and the lower limit. We continue. Now, the first bracket is going to be for the upper limit. So you're going to write 2 natural log sec x. Then here you write the upper limit, which is 45. And then you subtract with the second bracket of the lower limit. But the integral inside the bracket is the same. It's going to be 2 natural log sec x. And then the lower limit is going to be 0. Guys, I repeat, these are limits, not powers. Just in case you get confused, these are just limits. Now, the next step here, you have to substitute wherever there is x with the limit. So let's continue. Y is going to be the first bracket. You're still going to write 2 natural log sec. Now, instead of writing x, you're going to put the upper limit, which is 45 degrees. There we go. Minus. You're going to write the same integral here, which is going to be 2 natural log sec. What is the lower limit? Which is going to be 0 degrees. There we go. I hope this makes sense. Let me create a little bit of space here. Now, when it's like this, you cannot use your calculator because you have sec here. So the best way of doing this, guys, is to use the inverses. Now, let's continue. Y is going to be the first bracket 2 natural log. Now, what is the inverse of sec? It's going to be 1 over cos, but 45. When it's like this, you can able to use your calculator. You do the very same thing on the lower limit bracket. Now, we can say 2 natural log and then 1 over cos 0. There we go. That is your lower limit. Now you can use a calculator. When you use a calculator, the first bracket is going to give you 0,693. And then the lower limit is going to give you 0. So our limit for this question is going to be 0,693 unit square. Usually we answer this with unit square. Guys, to add on this, whenever you're calculating the definite integral, avoid adding plus c. You don't add c because these are definite integral. Even if you do add c, they're gonna subtract each other because you have this negative here. And at the same time, the lower limit, it's always subtracting the upper limit. So the integral of the lower limit will subtract the integral of the upper limit. All right, so here we decided to use the inverses because you don't have sec on your calculator. Unless you do have sec on your calculator, it's fine. But if you don't have sec on your calculator, rather use the inverses, which is 1 over cos 45. And then you just substitute, you put this on your calculator, you get 0,693. And you put that on your calculator, you get 0. So the final answer is 0,693. Guys, this is how you do definite integral. Just in case you didn't understand how I did this, you can leave a comment in the comment section. I'll try to explain to you to my level best. And again, at the same time, there is a video that explains the definite integral in depth. So you can go to the description, click on that video, and also the very same video will pop up on the top right of this video here. All right, guys, we are done with 5.2. We're going to do 5.3. So if you haven't subscribed to the channel, subscribe to the channel. And also, if this question helped you to understand the definite integral, do not forget to like and also share this to your friends. If you have a comment, you can also comment. All right, guys, let's go and do 5.3. Right, guys, now that we're done with 5.2, let's look at 5.3. Now, 5.3, here's our 5.3 here. We'll copy this question, paste it where there is space, and let's solve it. All right, guys, let's look at 5.3. Now, 5.3, they want us to simplify this here. Now, as you can see, we're still integrating because we still have a sigma here, and also we have dx there. So we are integrating with respect to x. But before we integrate here, we need to simplify first. When you look at the numerator, we have 3 multiplied by x to the power of 3 minus 81. And we look at the denominator, we have 2x minus 6. So before we integrate this, we need to simplify it first. So let's simplify this here. Now remember, when we simplify, we keep the sigma as usual and dx. So let's start with our numerator. Now, when you look at the numerator there, we have the common factor. Guys, before you simplify, always look for a common factor if there is one. So we have a common factor here, which is going to be 3. So we take out this 3, and then inside the bracket for the first term, we're going to be left with x to the power of 3. Now, when you look at the second term, when you take out the common factor, which is 3, we're going to be left with negative 27. There we go. And then we divide. We also have the common factor there, which is 2. We take out 2 as a common factor. On the first term, we're going to be left with x, and the second term, we're going to be left with negative 3. Right, let's not forget that we still have dx. Remember, we haven't yet integrated. All right, so when we look at this as well, we need to simplify it further. When I look at the numerator here inside the bracket, we have x to the power of 3 minus 27. This here, guys, is actually the sum and the difference of two cubes. Just in case you don't know much about it, this is actually the formula for the sum and the difference of two cubes. If we have x cubed minus y cubed, the answer is going to be x minus y multiplied by x squared plus xy plus y squared. There we go. Whenever there is a negative between the term, this is how you do this one. When there is a positive for the very same between the two terms, this is how you do it. It's going to be x plus y, and then we want to have x squared minus xy plus y squared. This here, guys, is what you call the sum and the difference of two cubes. So the one that we have here, guys, is this one here, because we have x cubed minus 27. All right, so let's simplify it further. So let's write sigma, and then we can take out this common factors on the numerator and the denominator. For the numerator, the common factor is 3, common factor is 2. Now, what we can do here, we have to first know how to simplify this. So let's look at the numerator. I'm going to open the bracket at the numerator. There we go. Now, look, we can see x to the power of 3 minus 3 to the power of 3. If you say 3 to the power of 3, you're going to get 27. This is going to help you to expand it further. Now, divide by x minus 3. There we go. Let's not forget dx. Remember, we haven't yet integrated. Now, we continue with our sigma. We are still simplifying. We have 3 over 2. There we go. Now, we can apply this method here. All right, so on the numerator, let me just create this line here. We can say the first bracket is x minus 3. Remember, this 3 here. And then the second bracket, we must have x squared. There we go. And then we say plus. Look at this. It's x multiplied by y. So it's going to be positive x multiplied by 1 here on the middle term of the second bracket. So in this case, it's going to be 3 multiplied by x. So it's going to be 3x. Right. Plus. And then when you look at the last term of this, you square the y. So in this case, our y is negative 3. So we can do this. Negative 3 squared. There we go. divide by, okay, then bracket, then divide by x minus 3. All right, let's not forget dx here. So let's continue because we're still simplifying. Let me just draw a line here, right? Sigma, and then we can say 3 over 2. Remember, these are common factors, and then bracket. Then we draw this line here. The first bracket on the numerator, we have x minus 3. And then the second bracket, we have x squared. We have plus 3x. And then we have plus 9. There we go. Divide by x minus 3 on the denominator, dx. Right. So when you look at x minus 3 on the denominator, we'll divide with x minus 3 on the numerator. So what we left with here, we left with sigma 3 over 2. And then bracket, we have x squared plus 3x plus 9. Then dx. Now, when it's like this, the whole thing now, it is simplified. We can start integrating. Do not forget, guys, these are standard integral. Right, so you can say y is equaling to. Now, these are common factors. You can write them as they are outside them. So inside the bracket, you integrate each and every term. Now, when we do the standard integral, we know that it's going to be x2 plus 1 divided by 2 plus 1. Right. And then we go to the next term. Now, the next term is going to be 3. And then we know that we're going to have x1 plus 1 divided by 1 plus 1. And then the last term, let's look at this term here, which is 9. Guys, 9 is a constant. When it's like this, we just multiply by a variable that we are integrating with respect to. So we can say 9 multiplied by x. Then we close bracket. Right. Let us not forget plus c. Right. Let me create more space. Right, if you continue here, our common factors, which is 3 over 2, we still write them there. Inside the bracket, we're going to write x to the power of 2 plus 1, which is 3, divided by 2 plus 1, which is also 3. Plus, we have 3 as a coefficient, and then we can say x to the power of 1 plus 1, which is 2, divided by 1 plus 1, which is also 2, plus 9x, close bracket, plus c. Do not forget, guys, this C is outside the bracket. And also C represents the indefinite integral. Let us not forget that one, guys. So from here, we multiply by 3 over 2, which are common factors. So we multiply everything inside with 3 over 2. On the numerator, we can say 3 multiplied by x to the power of 3. This is going to give us 3 x to the power of 3. And then on the denominator, we have 2 multiplied by 3. This is going to give us 6. There we go. Now we continue. Second term. Now we have 3 multiplied by 3x squared. That is going to give us 9x squared. On the denominator, we have 2 multiplied by 2. This is going to give us 4. The last term, we have plus 3 multiplied by 9x, which is going to give us 27x divided by 2. Now that we remove the bracket, we can say plus c. Now, when it's like this, guys, it's not yet simplified. So I'm going to continue this side. So we can say y is equal to, let's look at the first term. We have 3x cubed divided by 6. We can say 3 into 6, it's 2. So we can say x cubed divided by 2. Now, the following terms, even if we don't do anything, we write them as they are. They are fine. We have 9 x squared divided by 4. There is no common factor there. It's fine. And then the second last term, we have 27x divided by 2 plus c. So, guys, this is our final answer. I hope you guys managed to understand this one. It was a bit tricky if you didn't know the sum and the difference of two cubes, because you couldn't able to simplify this equation that we have here. But I think this question was not that difficult. But just in case if you find it to be difficult, you can leave a comment on the comment section and you can ask a question wherever you got lost. And also you can go to the description where I've solved a similar problem like this one, so you can go and watch that problem. I will leave the link on the description, and also I will leave the same link on the icon that will pop up on the top right of this video. Guys, I hope you managed to understand this one. It wasn't easy, but it wasn't that difficult. Alright guys, if this part of the video helps you to understand how to integrate this type of a problem, do not forget to like, share, comment, and also subscribe to the channel if you haven't subscribed to the channel. Alright guys, so this is 5.3. We are done with 5.3. How about we do 5.4? Right, let's look at 5.4. Now 5.4 consists of two questions. So we're going to start with 5.4.1, and then we're going to do 5.4.2 later on. So let me just copy this 5.4.1 and then paste it with a space, and let's solve it. Right, here's our 5.4.1. Now, they want us here to sketch the graph of y is equaling to 4x squared, and another graph which is x is equaling to 2y squared. And they want us to clearly indicate the area as well as the strip. So when it's like this, guys, we have two graphs here. We have this one here and that one there. Now, when I look at this graph here, this is actually a parabola because you have x squared, right? And this one here, it's more like an inverse of a parabola. Now, in order for you to draw this graph here, guys, you don't really have to stress that much. For the fact that this first graph here, the parabola graph, it has a positive coefficient, it means that it's going to face up. But then for the fact that it doesn't have B and C, the x coefficient and the constant, it means that it's going to pass at 0 point. Right, but there's another way of drawing this graph here. You can use the table, which I'm not going to use it because it's very, very simple to draw this graph. Right, now as for this one, it's also the same way, guys. It's just that it's going to be facing this direction. All right, so let me first draw the Cartesian plane so that you can able to draw this graph. All right, guys, now that we're done drawing the Cartesian plane, let's draw the y is equaling to 4x squared graph, which is a parabola. Remember, the parabola, when it's like that, it's gonna start at 0. So we can say this graph here is y is equaling to 4x squared. Remember, guys, it is passing at 0 point because it doesn't have B and also it doesn't have C. So when it's like this, it's gonna only cut at 0 point and it's gonna face upwards because our 4 is positive. Now let's look at the other graph, which is x is equaling to 2y squared. Now this graph here of x is equaling to 2y squared is gonna be facing this direction here. Also, the very same graph here is gonna be cutting at 0 point. Remember, guys, you can also use the table method to draw these graphs. I won't using the table method because it's very simple to draw these two graphs. So it's gonna cut at 0. So obviously this point here. So this here we can say this graph is x is equaling to 2y squared. Now we managed to draw these two graphs here. Now it's time for us to clearly indicate the area. Now, in order for you to indicate the area is between these two graphs. So this is the area that they're talking about here. So this is the area when they say clearly indicate, and then they say you must also indicate the representative strip as well. Now this strip here, guys, it should be between this point, the point of intersection. So we have the first point here and we have the second point, and also it should be within the highlighted area. So you can put a strip just anywhere as long as it's within this here. As for now, this is how you do it, guys. Don't put it anywhere other than the shaded area and between these points here, and then you just write change in x. So this is your representative strip, guys. Basically, this is how you draw or solve this type of a problem. Now we're gonna continue on this question, on question 5.4.2. But this is how you actually solve this one, guys. You draw these two graphs, and then this area you indicate because this is an enclosed area caused by these two graphs. and then you show the representative strip within the enclosed area. All right, guys, if it so happened that you didn't understand how to draw or what happened here, you can leave a comment. I'll try to answer you to my level best. And also, if this helped you to understand how to solve this type of a problem, do not forget to like, share, comment, and also subscribe to the channel. Now that we are done with 5.4.1, how about we do 5.4.2, which is a continuation of this. So we're going to use the very same graph to do the next question. All right, we are done with 5.4.1. How about we do 5.4.2, which is this question underneath here. And it's the last question, guys. So I'm going to copy this question here and paste it where there's space. And then let's solve it. Right, let's look at 5.4.2. They want us to calculate the magnitude of the area enclosed between these graphs here. Let's call this one graph number 2, and this one, let's call it graph number 1. So these are the graphs that we drew earlier with the aid of integration. So they want us to calculate the enclosed area between these two graphs with an aid of integration. Now, before we start calculating here, there are certain things that you need to understand here, guys. First of all, we have these two intercepts. Let me just highlight them for the last time, where this graph, they intersect to each other. Now, the first intercept, we know that is at the origin. So the x value is 0 and the y value is 0. So we are fine. But the second intercept, it's where we need to find the x value. What is our x value here? Because we're going to use the x values of this intercept as our limit. The one on the origin, we can say, is the lower limit. And then the one for point 2, we can say, is the upper limit. Right? Because in order for us to calculate this area, we need to use the definite integrals. And when you do definite integrals, we have to have upper and the lower limit. Now, we need to find the x value then. How are we going to find this x value for the upper limit? Very, very simple. What you can do here, we can use the substitution method to find those values. So we can say substitute 1 into 2, or vice versa. Really up to you. You can substitute 2 into 1 or 1 into 2. But let's substitute 1 into 2. All right. So we can say x is equaling to, remember, this is equation 1. So we can say 2, wherever there is x, we substitute with y. What is y? It's equation 2, which is 4x squared. So wherever there is y, we put 4x squared. We can say 4x squared. But let us not forget that equation 1, our y is squared. We can square it there. So from here, guys, we just solve for x. Now, on the left-hand side, we still have x. And then on the right-hand side, outside the bracket, we have 2. Inside the bracket, we have 4 to the power of 2. The 2 that is outside the bracket is going to give us 16. And then we also have x to the power of 2 to the power of 2. That is going to give us x to the power of 4 inside the bracket. On the left-hand side, still, we are left with x. And then now we have to remove the bracket by multiplying by this 2. It's going to be 2 multiplied by 16. That is going to give us 32 x to the power of 4. Now we can transpose this x to the other side, and then we left with 0 is equaling to 32 x to the power of 4 minus x. Right, so on the left hand side we still have 0, but on the right hand side we can take out the common factor, which is x, and then inside the bracket we're left with 32 x to the power of 3 minus 1. Right, now if we solve for x, this x here, this one here, we can say x is equaling to 0. And now inside the bracket we can transpose this -1 to the other side. We can say 32 x cubed is equaling to 1, because we transpose this 1 to the other side. Now we need to solve for x on this one here. Now we can say, we can divide by 32 throughout, divide by 32, and then we have x cubed, and then we have 1 over 32, because 32 divided by 32, we're left with x cubed. Now we need to get rid of this x cubed. Let me just do it up here. So we can cube root this x cubed. Let's do it because we are looking for x. So cube root here. There we go. If you cube root here, this is going to give us x, and then this one here is going to give us 0,315. There we go. So this here, guys, is our x on upper limit. So we can say this x here is 0,315. Now that we have the lower limit, which is x is equaling to 0, the upper limit, which is x is equaling to 0,315, we can start calculating for the area. So let me just create a little bit of space here. All right, guys, now that we've created space, let's calculate this area using integration. Now we're going to use sigma, and now we have our upper limit, which is 0,315, our lower limit, which is 0. Do not forget, our limits are x values that we just calculated here. This one here and that one there. Then there's something that I need to inform you about, guys. Now, we have to subtract these graphs, but how do we do that? Now, let's look at this green graph. When you look at the highlighted area here, the green graph is on the top of this one here. It's at the top there. So this basically means that the green graph, which we called it 1, you can say y1 minus y2 dx. So we will be integrating graph 1, which is this one, with graph 2. So we can say this is y1, that is y2, based on what we named them earlier on. Y1, when you look at this enclosed area, is at the top here, guys, while y2 is at the bottom there. So that's the reason why we are subtracting. It means now we need to make y1 be equaling to y. Remember, y1 is x is equaling to 2y squared. Now, if you can make y subject to the formula, we have to divide by 2, and then we have x over 2 is equaling to y squared. But then we don't want y squared. Now I'll continue here. It means now we have to square root both. So if we square root both here, we're going to have the square root of x over 2 is equaling to y. You can rewrite it as x to the power of half over square root of 2. All this is equaling to y. So instead of substituting the original equation, we have to substitute this one because we are integrating with respect to x. So let's continue. I'm going to continue here. Right. The upper limit is 0,315. The lower limit is 0. Now, y1 is going to be x to the power of half divided by the square root of 2. Right. Minus. Now, y2, it's very simple. It's just going to be 4x squared because already y2 is equaling to 4x squared, just in case you don't remember. Then we close bracket, then we say dx. Right. I hope you guys can able to see this. This is a very long question, so I need you guys to brace yourself. So I'm going to create more space, and also I'm going to zoom this one in. Okay. Right, let's continue. Now we need to integrate this. If this is already simplified, let's integrate. So I'm gonna integrate y is equaling to, remember, these are definite integral. So we need to integrate this one, and these are standard integrals. So you can say x to the power of half plus 1 divided by root 2, and then multiply by half plus 1. There we go. Minus 4x2 plus 1 divided by 2 plus 1. Let us not forget. And then the upper limit is going to give us 0,315, and then this is going to be 0. Now let's simplify. Now we know that x to the power of half plus 1 is going to give us 3 over 2. Divide by. Now it means we have root 2 multiplied by 3 over 2. There we go. Minus. Now we can say 4 x to the power of 3 divided by 3. Let us not forget the upper limit 0, 315 and 0. Right. So let me create more space. Is it y open bracket x to the power of 3 over 2 over, we have root 2 multiplied by 3. We're going to have 3 root 2 over 2 minus 4 x to the power of 3 over 3. And let's not forget the upper limit 0, 3150. Right, so let's simplify the first term here. You can put this on a calculator, and then this one is going to give you 2x to the power of 3 over 2 divided by 3 root 2 minus 4x to the power of 3 divided by 3. And then the upper limit, which is 0, 315 and 0. Right, I'm going to continue here. Now that we are done, it's time for us to substitute. Let me just create the space. So when we substitute here, we're going to have y is equal to open bracket. Let's start with the upper limit. Wherever there is x, we substitute with the upper limit. So it's going to be 2. Wherever there is x, we're going to put 0, 315 to the power of 3 over 2 divided by 3 root 2 minus 4. And then we have 0, 315 to the power of 3 divided by 3. This here is the upper limit minus the lower limit. This time around, wherever there is x, we substitute with the lower limit. We have 2 and then 0 to the power of 3 over 2 divided by 3 root 2 minus 4. Wherever there is x, we put 0 to the power of 3 divided by 3. There we go. So y is going to be, if you use your calculator, what you're going to get here is 0, 0.047 minus, if you go to the second bracket and use the calculator, you're going to have 0. So your final answer is going to be 0, 0.047 unit square. Guys, this is how you do this question here. It was a bit complex. I hope you can see how long it actually took us to do this one. So I'm going to try to zoom it down so that you can see how much of work we did here. I hope you managed to understand this, guys. And if it so happened you didn't understand, do not forget to leave a comment. I will try to answer you to my level best. But to be honest with you guys, this needs you to rewatch it over and over again. And then you can able to understand where you got lost. It's easy to get lost on this question. It was a bit complex, this one. But if you understand that you need to calculate the area using integration, and also you need to find your upper limit and the lower limit, then this question is not that difficult. Remember, your upper limit and the lower limit are based on your intersection. Right. So guys, this is question 5.4.2. Do not forget to like and share this video if this part of the video helped you to understand. And also, guys, do not forget to comment on the comment section. If you haven't subscribed to the channel, subscribe to the channel. We are done with question 5, and also we are done with the whole question paper. So just in case you want to watch the other questions, I will leave the playlist at the end of this video. Click on that playlist so that you can be able to watch the other question papers. All right, guys, I hope this helped you. Thank you very much, guys, for watching. Until next time, do not forget to hit the bell notification because I'm going to do other previous question paper. Thank you very much, guys, for watching. Until next time, cheers.